Hello everyone, my name is Nayan Desale and my project is computer vision and animals, detecting and analyzing the activities of animals. So the use case of this project basically focuses on the sanctuary, jungles and natural reserves where a lot of ecologists, tourists, and wildlife photographers are interested in observing the predators and their movement, monitoring those animals. And some wildlife photographers are interested in observing which predators are chasing which herbivores. Um, so the end goal here is to detect, and categorize the animals using the video captured in real time and detect if an animal is in motion or not. So this is the basic introduction about the project. So let's get started. So here I did some research about the related work done before. So there have been many attempts to automatically identify the animals in camera trap images. So camera trap are basically the cameras which are placed inside the sanctuaries, and it will capture the image whenever it triggered a movement. So the first related work is it's released by U uh, U and it is based on the sparse coding spatial pyramid matching. So it uses the linear support vector machine. So basically, the drawback of this system is, first of all, it reaches up to 82% of accuracy on its own data set. But the major drawback of this system is the data set is was really small. So it wasn't trained on a huge database, which makes it non-practical. It was just like released. So second paper published was related to the deep convolutional neural network by Chain. So it categorizes 20 animal categories in their own data set. Um, so it uses the ensemble video object cut method. So this cut method basically cuts the crops the image of the animal from the image of the animal from the captured video, and then it trains its model. um, so here um, um, since this automatic crop method it gave a lot of empty images, so which gives them only 38% of accuracy since there are a lot of empty images. And the third approach was third paper published was by Gomez. It is related to the very deep convolutional neural networks to classify 26 animal species. So the dataset used here was snapshot Serengeti database. I will talk about that in a in the next slide. So the drawback of this model is it reveals a lack of confidence in low quality camera trap images. So let's move forward to the data source. So here, as I mentioned before, the Serengeti snapshot database is the main data source for this project. And what is this? So Serengeti snapshot is a world's large project published to date. So Serengeti snapshot is a sanctuary in Tanzania. So there were 225 camera traps were installed at different places in that national park in Tanzania. And so they were camera traps, so they capture the image as soon as they trigger a movement in it. So let's see next. So as I mentioned before, this Serengeti snapshot database, it consists of 1.2 million capture events, so 1.2 million um, images of 48 different species. So these images were labeled by 28,000 um, registered and 40,000 unregistered volunteered citizen scientists. So these people manually saw those images and they labeled those images. So this is the actual so this is the uh, diagram diagram representation of that this process. So these are the cameras on the left hand side, then they are stored in the database. Then the biologist, they uh, first categorize whether the images contains the animal or not. So some images are the empty images which doesn't which don't contain any um, animal in it. So they categorize them first into the images with animal and without animals. We don't need them. So after that, the biologist again classify those images which contains animals um, into the classes, into the 48 different classes, because there were 48 different species. So they say that like 75% images labeled by scientists and volunteer were classified as empty of animals, which doesn't contain animal, as I mentioned before. So therefore, the process of data filtering and the deep learning, uh, therefore, for the process of data filtering, the deep learning model will take an image as an input, and it will output two probabilities describing whether an image contains an animal or not. This is a binary classification problem. So here are some examples of those images. So first image contains animal, so it should label it as it contains animal, and the rest of the two they don't contain animal. So let's move forward to the model building. So basically we divided this overall problem into two tasks. First one is detecting the images that contains animals, animals and identify species, and second one is identify their movement. So the first task is detecting the images that contain animals and identify species. So here, um, actually there were 100k images, around 100k images. So as the database contains only the images without the labels, we are going to filter only the images which contains the animals, and we're going to pass it to the next phases. So here we train here they train the models, a lot of models like AlexNet, VGG, and Linet, ResNets, and all the models they have almost approximately like this accuracy is greater than 95.8%, which is pretty good. But the VGG model, VGG19, which consists of 19 convolutional layers, it shows the best accuracy among all the models of like 96.8%. So the VGG model is shown below here. So as I mentioned before, there were 19 convolutional layers. So here you can see some the max pooling layers, which pulls the maximum feature, uh, which detects the feature and highlights it, and then convolutional layers, which does the convolution operation, and finally the select layer, and then it will determine whether it contains an animal or not, and if it contains animal, which animal it is. So here in this case it's wolf. And then um, so this is the image classification and detection. So VGG content, here's the math behind the VGG model. So this is just a simple convolutional formula where y is contains the output of the convolution, w is the actual image, x is the tensor, which we call as which we call it as a convolutional filter. It may be 3 by 3 or 5 by 5. After that, uh, um, here uh, I have I have created an application in Android using a TensorFlow API, TensorFlow Lite API, which has a built-in data set, and it uses VGG 16, which is pretty much similar to the 19, except it has 16 convolution layers. So here it will show you which animal it is. I'm gonna play this video. So um, this is the application. So this is the gazelle. So as you can see at the bottom of this